So just a quick show of hands. Those of you in the room whose faces I recognize, many of you, who are involved in ATSC 3.0 development at a fairly regular level. We have one. Come on. Yep, quite a number of people. So first of all, thank you. It's been a long road and we're nearly at the end. So what we'll be doing today is giving everybody a little bit of a technical deep dive. For me, I'm going to be providing you with an overview, and then even those of you who raised your hand and said, yes, I do this every day, including myself, are going to learn some new things this afternoon as we get more into the technical deep dives of certain aspects of the system. So, okay. A little bit about the ATSC. And we won't dwell too long on many of these slides because we're running a little bit late, but just to give you a sense of the scope of this organization and the scope of the project. It's a standards development organization, as you know, and it is an open due process. There's approximately 150 member organizations that are part of ATSC, and new ones signing up all the time. The mission statement: create and foster implementation of voluntary standards and recommended practices to advance terrestrial digital television broadcasting and to facilitate interoperability with other media. So hopefully with ATSC 3.0 we are fulfilling that mission. And just a little bit of a slide on members. It's probably not even up to date because it changes a lot. So a little bit about participation, and I want to spend just a bit more time on this slide to give you a sense of the level of participation that's going on. We have 373 individuals on the reflector system that we all know and love called CAVI. If everybody knows what the word CAVI means, then you spend way too much time working on this stuff. But it's a tremendous amount of effort from a large number of individuals. And in the organizations, we have a broad range of types of organizations, lots of broadcasters, consumer electronics manufacturers, equipment vendors, R&D laboratories, universities, the list goes on, and this list is not complete. This is just a starting. And also, in terms of the international participation, it's been fantastic. We have participation from Canada, China, Europe, Japan, South Korea, the United States, and there's probably a few missing there too. So it's been a tremendous effort, and as one who chairs these groups, it's been a real pleasure to take these different ideas and these different people coming from different walks of life in different areas of our organization and try to guide the group to what everybody ultimately hopes to come to agree is the best decision for a given point in time. So it's been quite a process bringing this lot together, but it is the brain trust of the world right now, really. So this is a little bit of kind of the obvious stuff. What are we trying to do here? We've been at this for a while. So what is the point? And certainly we want to add value. We want to enable some new business models. We want to be able to reach more viewers on more devices. And we want to address all of changing consumer behaviors. In other words, we need to keep up with the Joneses. You know, we've got streaming vendors that can make changes very, very quickly, and we need to be able to make changes quickly too. So that's a lot of what we're doing here. So we said, okay, let's build something. And we came up with something that we want to share with you today. Something like that. All the people after me are going to explain that lot to you. Okay, so I'm just going to give you a quick overview of the different parts of the system and just to whet your appetite about the next things coming this afternoon. So the physical layer includes the common system elements, bootstrap, modulation encoding that we all call ModCOD, waveforms, core broadcast services, and a lot of flexibility. This to me is the most interesting graphic that I ever look at, where you see the single point, which is the green star, which is A53 or ATSC 1.0, and you see the points along the red, which indicates the line, which are all the different operating points of ATSC 3.0. So in ATSC 1.0, we were locked into a single way of operating. In ATSC 3.0, we have a whole spectrum of choices. Transport layer, so this is one that's near and dear to Rich's heart. Again, we'll leave the description of all the lovely charts to the folks that come after, but this is essentially the protocol stack. And the important thing to pull out of this is that you have broadcast and broadband. These two things are being married together with ATSC 3.0. And it's kind of funny because a lot of companies, including my own and many broadcasting companies, have what they call the broadcast guys and the digital guys, or the over-the-air guys, and they don't necessarily talk to each other. Rich said in my background, I used to work with a company called Back Channel Media, and we had a little bit of an interactive service, and it was the kind of thing where you click on something you saw on TV and someone would get an email. So we thought, this is the best idea ever, and we went and talked to the broadcasters, and we said, hey broadcasters, you know, we're going to put this thing on TV and people can click on the ads and then they can go online and get the stuff online. And they said, oh, you need to go talk to the digital guys. So we would walk down the hallway and talk to the digital guys, and the digital guys would say, you going to put something on the air? Well, yeah, you know, the interactivity goes on the air. Oh, you need to talk to the over-the-air guys. There was no discussion between the digital guys and the over-the-air guys. And I know that's changing dramatically in our industry, and I think that ATSC 3.0 is going to help us migrate along that path, because it's an extremely important path for the broadcast industry to go down, is to consider the concepts of the hybrid broadcast broadband delivery. And that's exactly what this protocol stack is all about. And on top of that, so we have the service delivery synchronization, service announcement, in other words, the program guide, interactive services, companion screens in terms of delivery of the signaling, and redistribution support and watermarks. And I think that this is the another key thing, which is part of this hybrid delivery. The whole thing is IP-based. IP packets over broadcast. And we think this is going to be a game changer for the industry. So a little bit about the applications layer. This is the layer encompassing video, audio, interactivity, accessibility, advanced emergency alerting, and basically if the customer sees it, hears it, or touches it, it's in this layer. Definitely working on advanced video and audio pieces, new codecs, wider color gamut, higher frame rate, and then the immersive and personalized audio, interactivity, which is based on web-based technologies, HTML5, CSS, JavaScript, and all those things that the guys down the hall in the digital office, they understand. And part of the reason for that is so that broadcasters can use the people that they're already using for web development for their TV application development, and those two things can be seamless. And then definitely advanced accessibility using IMSC1 captions, dialogue enhancement, descriptive video service, oral versions of the emergency crawls, and much more in there. And then the advanced emergency alerting is another piece which is extremely interesting, I think, across the industry, including into the regulatory area, which is to be able to send really in-depth information about what's going on. So if you're in Santa Rosa, what should you do? Should you evacuate? Should you not? And if you were to evacuate, where would you go? So as I mentioned, we've been on this path for a little while. I've been involved since, I think, 2011, when the planning was going on. And we started working on the retirements. The requirements. Boy, that was funny. I'm too young to retire. The requirements, which was 2011 through 13, you can see we spent a couple of years. We actually did an international call for requirements for this new system, brought all of that into the fold and hashed through it over a period of 2 years. And then we started developing kind of concurrently with the physical layer coming first. And we're hoping to have the completed standard by the end of this year. I'm looking at Mark Richard. He's going, yes, you will have the completed standard this year. So I better get off of this podium and go get to work. So this is where we are at. We have a number of documents which comprise this standard. And you see that we have mostly finalized standards there in the lower floors. We have a few proposed standards which are well on their way to becoming finalized. We have 3 candidate standards which are mostly baked, and then we get into the draft standards. So what do we mean by done? That's a good question. So there's the working draft stage, which is a document that's being worked on within a group. The candidate standard ballot, so that means that the group is ready for it to go public and let the outside world kick the tires. Then we have a long phase when the candidate standard is there and we update it as we need it when we get feedback. And when the candidate standard has kind of died down, the feedback has kind of died down, and people are pretty happy with it, then we go into the proposed standard ballot, and we resolve any comments, we lather, we rinse, we repeat, and then we finally do a full member ballot, and that's when we get to the final standard, i.e. done. So all of that stuff in the lower box there is quote unquote done. But there's one thing I want to say about that, which is that we don't really want done to be meaning it's engraved in stone. If we want to keep up with the Joneses, we cannot have this be a 20-year standard that never changes. It's got to be extensible. And we spent a great deal of time and effort making sure that every aspect of this is extensible so that receivers don't get orphaned. Receivers can gracefully ignore the new things, and we can continually evolve the standard. So again, done is in quotes. It's done, but we expect and hope that it's an evolving and living document. So this was one of the headlines from NAB 2017. I have to say it was a very proud moment, because you get started on this thing back in 2011, you know, doing some planning or whatever you're doing, and you think to yourself, well, we're going to spend a whole lot of time working on some shelfware here. It's going to look great up on the shelf, and that's going to be that. No, looks like we're really going to get deployed. And one of the headlines was it reaches mainstream status, which I thought was very exciting. There's a lot of buzz about it, and there's a lot of commercialization activity going on as people think about how to make a return on investment with ATSC 3.0. This was a great moment. South Korea. So it is actually launched and on the air in South Korea. They launched on May the 31st, and we had an opportunity in March to go and look at some of the broadcast stations and see what they're doing there, and what an amazing tour. So the South Koreans are ready to go. They're getting ready for the Pyeongchang Olympics in 2018, and we're looking forward to that. So that's your just lighthearted introduction to what's really going to come. So sharpen your pencils if you want to take notes. So multiple physical air pipes and single frequency network for ATSC 3.0 field comparison test of LDM and TDM based on ATSC 3.0. That'll be Gerard. He's going to be great. Next generation broadcast technology for the accessible audience with Chris Homer. NAB ATSC 3.0 pilot gateway. And who's that? Sovang, right, of course, duh. Oh, field comparison test of LDM and TDM based on, oh, no wonder. Bomi Lim, thank you. 1 and 1A. Development of 8K UHD cameras and image sensors for full-featured 8K compactness and high-speed imaging and recording from Shimamoto, who I just met. And securing ATSC 3.0 apps and signaling from alteration by cryptographic signing, and that's going to be Adam Goldberg. So, enjoy. Thank you.
Well, quick things. First off, does anyone have any questions for Madeleine? Okay, please, I guess we need to use the microphone. It's okay. Thanks for getting us back in time.
Most of you who know me know that my interest is in translators, and the question is, if we've got a translator now and its primary station changes over, will we have to change the input of the translator? Because right now it kind of processes the 1.0 signal to take advantage of the error correction. Will we still can we keep our present input equipment?
Well, if Dennis Wallace is still in the room, who presented earlier today.
And then my second question is, will the output circuits remain the same for the same transmitter power?
I would need to redirect your questions to someone who's more in tune with the physical layer. More Dennis, right. More Dennis or more Joe Cecilia maybe,
Well,
or more.
I'll
but-
expect an answer.
Or
when
Merrill
it's
can
here.
answer the question potentially.
Okay. I'll wait for the answer.
Thank you.
I'll wait for Byron to sit down. So Byron, with respect to the second one, in terms of transmitter power, it's essentially the same whether it's 1.0 or 3.0 because that's a regulatory function. And but the 3.0, Madeleine mentioned modulation and coding. There are a whole range of choices. And so you can have the same level of performance that you have today at the same power, or you can have better performance, or you can have a higher data rate, depending on which modulation and coding scheme you pick. But the power will be the same because that's a regulatory function. And so the translators should track what the station that's carrying does. Correct.
Thanks, Merrill. Thanks, Byron.
So, an appreciation. Here's your